In just 4 minutes, let's leverage the Chainstack Covalent Integration SDK as well as an RPC node to query a list of smart contracts deployed by a specific address. So if you've ever watched a Byte-Size BUIDLing video before, then you probably know that I enjoy very unique data tasks. I believe that if you can understand how to leverage multiple technologies to achieve a unique task, you'll learn more and have an easier time with more general development. So in my never-ending search for unique data tasks to cover on this series, I came across a tweet from the head of growth at DeForm, Albert, in which he was asking if there was a blockchain API provider that would allow you to check if a given wallet address has ever deployed a smart contract. Now, if you've watched any of these videos before, then you may realize the direction that I'm going here. Traditional JSON RPC methods actually lack the ability to directly query a historical list of transactions that involve a specific address, which is inherently what you need to query to know if an address has ever deployed a smart contract. Doing this with exclusively RPC nodes would require manually indexing transactions on the blockchain. This is where the utility of data APIs really shine. And in specific response to this tweet, we actually built out a function within the Chainstack Covalent Integration SDK that does just this. So in just 4 minutes, I'll learn how to leverage this, as well as utilize RPC nodes to learn more about the deployment transaction itself and ultimately return a list of contracts deployed by a specific address. Alright, so before we get started, let's quickly talk about the structure of this script. Essentially what we'll be doing is leveraging 2 different libraries. The Chainstack Covalent SDK, this will be used to actually fetch the contract deployment transactions, and we'll also be using Web3.js to get the transaction receipt of the transactions returned by the SDK so that we can retrieve and log the deployed contract addresses. So we can start by importing those 2 base libraries, the Chainstack Covalent SDK and Web3.js. So now we have Chainstack API and Web3. Before we continue, we'll need an RPC URL as well as a Chainstack platform API key. We can retrieve these things by going to the Chainstack console. We can start with the RPC, so we can head over to our test4 project, then click on get started. In this case, I'll be doing Sepolia on Ethereum, but this video applies to a wide range of chains as well, and we'll click next. And here I'm going to deploy an Elastic full node, and I'll deploy it in Amsterdam on Virtuoso. I'll also leave the name as node 1. Now we can go ahead and click on join network. All right, now we can head in here and grab our HTTPS endpoint. Now we can define our base Web3 variable. We can just call this Web3 and set it equal to new Web3 and then our RPC endpoint. We'll also need our Chainstack platform API key for the Covalent integration. So to get that, we can head over to the marketplace, click on Covalent. Now we can create a new platform API key. And now that we have the API key, we can define our base SDK variable. We can name this Chainstack API and set it equal to new Chainstack API, paste in our API key there. All right, so now we've imported the 2 base libraries, the Chainstack Covalent SDK, as well as Web3.js. We defined our Web3 variable with a Sepolia RPC node, and we've generated a platform API key for our Chainstack API variable. So now what we can do is actually define the parameters for the method that we're going to call on the SDK. We can name this fetch contract deployment transactions params. And in here, we'll only need to define 2 key parameters. We'll need to define chain name. In this case, it can be eth-sepolia, and we'll need to define the wallet address. All right, so now that we have the key parameters defined, we're going to shift it up a little bit and actually create a function called getContractDeploymentDetails. We're going to actually utilize this function later on in our main function to make a JSON RPC transaction receipt call and retrieve the contract address of the deployed smart contract. So this will be asynchronous, call it getContractDeploymentDetails, and it'll take a parameter called txhash. And then in here, we can define a variable called txReceipt. This will be equal to await web3.eth.getTransactionReceipt, and then we can pass in the txhash. And then we'll go ahead and return txReceipt.contract address. So now we can define our main function. This function will contain the call to the SDK as well as our print statements. So it'll be asynchronous and we can just call it main. And then in here to start, we can define a variable called contract deployment transactions. This will be a direct call to the Chainstack API object. We await Chainstack API, and then we can call the fetch contract deployment transactions method, and then of course pass in the parameters variable that we defined above. Now with that defined, we can loop through all of the transactions that it finds and print out the details. So we can do for transaction of contract deployment transactions, and then now we can call the getContractDeploymentDetails function to get the address of the contract deployed in this transaction. So we can define that in a variable called address, then await getContractDeploymentDetails, and then transaction.txhash. All right, so now we can go ahead and just print the basic details. Do console.log, transaction hash, transaction.txhash. And then of course we can also log the contract address. And perfect. At this point, what we've done is imported the 2 base libraries, the Chainstack Covalent SDK and Web3.js. We've defined our Web3 object and used a Chainstack Elastic Sepolia node. We've defined the Chainstack API object using a Chainstack Platform API key. We've created the parameters for our method call on the SDK, defined the function getContractDeploymentDetails, and we've defined our main function, which calls the SDK method and prints the result. So now all we have left to do is run the main function and see if it works. So as you can see, it looks like it works. With this address, I've only deployed 2 contracts. So let's head over to Etherscan and make sure that it got all of the addresses and information correct. And as you can see, this is the contract deployment transaction from 8 hours ago. It created this contract. And then of course, this contract address adds up with our contract address that we found here. So again, as usual, a very niche but interesting data task that provides interesting insight into the contrast between base RPC node calls and data APIs. When used together, you can create really rich data experiences with very few lines of code. If you'd like to learn more about the Chainstack Covalent Integration SDK, I did create another video on the same topic a few weeks ago in which I query and print out all of the transactions that involve a specific address. If you'd like to check that out, the link will be below this video. Additionally, this was episode 13 in Chainstack's Byte-Size Building series. You can watch the other 12 episodes at the link below.